All right, hello 20-1 students. So today we're going to be looking at the second part of the Sine Law lesson. So if you remember last time we started with lesson 2.3 part 1 where we basically got an introduction to what the Sine Law is. So today this is still the Sine Law, but it gets quite a bit more in depth because we're looking at something called the ambiguous case. And usually this seems to be the thing that most students struggle with the most in this unit. So I'll try and give you guys, some good tips and hints and stuff for working with the ambiguous case because it can be, a little bit tricky to work with. So we'll start out by looking at a quick little investigation. So if we're given triangle ABC, so here's these two, where we have side length A is 4, side length C is 5, and angle A is 44 degrees, and we need to find side B. So looking at this triangle here, we see that A is 4, C is 5, and A is 44. But looking at this triangle here, we see if A is 44, C is 5, and A is 4, we have a totally different looking triangle, right? And so depending on which one of these we think is accurate is going to depend which side length of B is correct. Now, if you were to do calculations using the ambiguous case, you would find that both of these triangles satisfy the given criteria, despite their different values for B. And of course, you can probably tell as well that there's going to be a very different value for C. Here we have an obtuse angle, and here we have an acute angle. So which triangle is correct if you use sine law? Okay, so let's say we're just going to use sine law. So we're just going to think about what we have up here. We have side A and angle A, and we're looking for side B, which means we need to have angle B, right? So in order to do that, we would first of all need to use, if we have a side and an angle that are corresponding, and we have another side, we can solve for that unknown angle that corresponds with this side. So we could solve for angle C right now, just given the information we have. And then, of course, we know that all angles in a triangle sum to 180, so then we can solve for angle B, right? And then if we know angle B, then we can solve for side B. So let's have a look here. First of all, we're going to solve for angle B by first solving for angle C. So we're going to find angle C by saying sine A, which is sine 44, divided by side A, which is 4, is equal to sine C, which is what we're looking for, divided by side C, which is 5. Okay, I'm not going to go through the math because we did that last time, but if you do sine 44 times 5 divided by 4, you'll get a decimal value, and then you have to do the inverse sine of that to find angle C, which is going to be equal to 60.26, kind of like an extended decimal there. So remembering never to round until you have your final answer. So in your calculator, keep that full decimal value. The next thing we want to do is solve for angle B, which is pretty straightforward. If we have two other angles, it's just going to be 180 degrees minus. Remember to keep that full decimal in there if you're doing this in your calculator. And then minus the original angle we had, which was 44 degrees. And that's going to give us 75.73, again a decimal degrees. Okay, so that's our angle B. Now we can solve for side B by doing the same original thing we did here, except for swapping out B for C. So we're going to do, for number 3, we want to solve for side B, which is going to be, let's see though, if we want to find a side, like I mentioned last time, it's usually easier if you use the flipped version of the sine law. So let's sorry guys, my mic just cut out there. So 4 over sine 44 is equal to side B, which is what we're looking for, divided by sine of angle B, which was 75.73 degrees. And so again, 4 4 times by sine of 75.73 divided by sine of 44 degrees is going to give us side B being equal to 5.6. Okay. So if we look at, we have this B equals 5.6, and this was the triangle that had a side length of B of 5.6. This one had 1.6. So if we do the sine law, if we're given this information, we can get an answer. But what if this is the actual triangle, right? And so sine law on its own can't distinguish between the two possibilities. Okay, so this is where the ambiguous case comes in. It's when there's more than one possible triangle, or sometimes no possible triangles. And even if there's only one possible triangle, the ambiguous case helps you to determine which one of those things is the case. Like, do we have 0, 1, or 2 possible triangles given this information? And then so it can help us to determine which scenario is accurate, and then it will also help us to determine the missing sides and angles. So one of the most important things for determining if you have an ambiguous case is if you have something called side-side angle. So basically, if you look at this example we had here, we were given side A, side C, and angle A. And so when we say that it's side-side angle, what we mean is the angle that we're given is not contained between these two sides. So if we go from side A to side C, angle A is not in between there, right? You would have to go around to side B first. So you always know that you have side-side angle if the given angle is across from the shorter given side. Okay, and then if that's true, so if you have a situation where you're given side-side angle, then you have no way of knowing which triangle the question is referring to, and so that's the ambiguous case. And we're going to look at how to deal with that. So like I mentioned, there's three possible outcomes for this ambiguous case when you're given side-side angle. The first one would be no triangle exists with the given measures. There's no solution at all. The second one would be one triangle exists, and that's what we normally have been dealing with. The other option is that you could have two distinct triangles given with the given measures, and they would both be accurate. Okay, so the big trick with the ambiguous case is determining which outcome applies to your triangle, and then also solving for the missing sides and angles for both triangles. You need to be able to calculate both. So I'm going to show you guys a set of steps that I find works the best. It makes the most sense for me. The textbook has a little bit of a different method for doing this. I'll kind of show you a little bit of the idea of what the textbook is showing you in the next page, but I just find this method makes more sense to me because with the textbook, I don't know, I just find like if I'm too reliant on drawings, then I get messed up, because if you don't draw it properly, then nothing really looks like it works right, even if it actually does. So with this method, you do draw your triangle, but as you can see here, there's cases of one triangle, no triangles, or two triangles. I still have a triangle drawn, and so the nice thing with this method is it doesn't matter if you've drawn your triangle correctly. It's not going to affect like your ability to determine which one of these cases we have and what the missing side lengths are. So in the first one here, let's imagine that we are told that we have angle A of 40 degrees. We have side length A of 20, and we have side length B of 15. Okay, so if we're given this information, one thing I would say is usually, I don't know why it works this way, but it does seem to be easier if you always draw your given angle into the bottom left corner. Okay, so I always start here. So 40 degrees is angle A. So I know that the side straight across from that is going to be side A, which is going to be a length of 20. Okay. Now, again, the nice thing with this rule, because a lot of students are like, well, how do I know, is this going to be B or is that going to be B? doesn't really matter with this method. So however you choose to, I usually am pretty consistent with how I do it, but it doesn't really matter how, like where you put it. So I'm going to go A, B, C. So side B is across from here, and it's 15. Okay, and so we can see that we have side, side, and then the angle, right? So alternatively, if you would have had like side, angle, side, so if you would have been given side C and side B with angle A, the angle is contained, and so then we don't have this ambiguous case. So remember, you're always looking for side, side, angle to determine if you have the ambiguous case. So now we have our triangle labeled. The next thing we want to do is to try to solve for angle B. Okay, and we can do that just using the sine law like we have so far. So we're going to do sine of 40, right? Sine A over side A, always use the ones that are paired together first, is equal to, we're looking for angle B, so we're going to put sine B on top here. And then we have side B is 15. Okay, so again, I'm not going to go through all of the math, but you're going to end up with angle B being equal to 28.82 degrees. So again, don't round your values there. Now the next thing we want to do is solve for something called B prime. So this is basically thinking about what might be a different value for B if another triangle exists. Okay, so and the reason we can kind of think of this is essentially if you think back to when we learned about like reference angles, what we're kind of doing here is thinking about that. Remember the cast rule? So if we have sine of angle B and it's a positive value, remember that that means that if we think about the cast rule, so remember we have CAST. So where is sine positive? It's going to be positive where all are positive or sine is positive. And so that means if we have an angle of 28.8 for our sine law, that means we could have an angle here in quadrant 1 with 28 being there, and here in angle 2 with 28 being there, but remember our standard angle is going to be an obtuse angle. And so that's basically what we're looking at in these triangle cases, is we're applying this cast law to a triangle and seeing that there's two possible variations for angle B. Now, even though there could be two variations for angle B, doesn't necessarily mean that you can actually make a triangle with that angle. Okay, so when we solve for B prime, we're doing the same thing that we did in this cast law. How would you solve for this standard angle if you knew that your reference angle was 28.82? Well, remember we would say we're at 180 and we're backing it off by 28.82 degrees. So we're doing 180 minus 28.82. And again, keep your full decimal, and that's going to give us, ooh, I kind of set that up not great, 151.18. Guys, the filled in notes are always going to be nicer looking because I have more time to do it. And I'm not thinking about teaching while I'm writing it. Okay, so there's the angle we're looking at, which makes sense given this, using our coordinate plane, right? 151. Now we need to figure out if we had 151.18 there, would that even make a triangle? So remember, basically what that means is if angle B was 151.18 and angle A was 40, we'd have to see, is there still room to make up 180 degrees? So essentially what we want to say is how much are the angles we already have, which is angle A, which was given, angle B prime, which we just solved for. So we do A plus B prime. Oops, I'm putting in a B plus there, I don't know why. Okay, A plus B prime, so this is the second possible triangle, is going to be 40 plus 40 degrees for A plus 151.18 degrees for angle B, and you can probably see already that that's not going to work because it's 191.18 degrees, right? And so what we would say is this is greater than 180 degrees, so basically there's no room left to make us a third angle in the triangle because we're already over 180 degrees. So now we would say that this is no second triangle possible. Okay, and I wrote out kind of in the filled in notes like why, because it's greater than 180 degrees, there's no angle C that's possible, and therefore we can't have a triangle. Now we also do want to confirm, did things actually work for this angle we calculated for angle B? So what we would do then is say angle A we were given plus the original angle B we calculated, not the one for the imaginary second triangle. So that would be 40 degrees was angle A plus 28.82, and you can probably see that that's degrees. So that gives us 68.82 degrees, right? So obviously we still have room to make it up to 180. So we're less than 180. So angle C is going to be 180 degrees for the total of the triangle minus angle A plus angle B, which we just figured out was 68.82. And that's going to give us, oh shoot, you guys, I didn't actually calculate that because all I really wanted to show you was the general trick of like how to figure this out. So yeah, you can go ahead and I'm not going to fill that in here, but this is how you would start, right? Now you would be able to solve for angle C for this one triangle that's possible. Keep in mind when you solve for the missing, like the only remaining missing side would be side C. So you could use your sine law, right, to solve for, if you have angle C now, you can use sine C and side C with what you'll probably want to use is your already given things in case you made an error with your calculations for B. So you would use that together with sine A or sine 40 over 20. Okay? All right. So what about the case where there's no possible triangles? So let's imagine you're given angle A in this case is 30 degrees. Side A is 10 and side B is 40. Okay, so again we have A, B, C. Side A is going to be 10, angle A is going to be 30, side B is going to be 40. Okay, so same exact set of steps. We want to try and solve for angle B first of all, and we're going to use the sine law for that. So sine of 30 over side A, which is 10, is equal to sine B, which we're looking for, divided by side B, which is 40. Sine 30 times 40 divided by 10, and then we do the inverse sine of that. So what we actually get here is sine B is equal to 2. So if you do sine 30 times 40 divided by 10, you'll get 2. Now what happens in our calculator if we do the inverse of that to solve for the angle? So we go second function sine of 2, enter, and this is what you get on your calculator, error domain. Value is not allowed in the function or command, right? So this has to do with where it's possible for different values of sine to fall in our coordinate plane like we looked at before. So if it says error, what that's telling us is there's no possible angle for these measurements. So there's not even one triangle, let alone two. So we would say error, so no possible triangle. And that's it, we're done, right? If there's no possible triangle, we can't solve for any additional imaginary or real measures. Okay, last one here, if we have two triangles. And of course, like going into your calculations, you'll never know which one of these is which is why you need to know these sets of steps. So given any set of data for a triangle, you wouldn't have this part here telling you that, but you'll know based on what happens as you go down the steps, you'll know which one of these is true. Okay, so for this one, let's say we have angle A is equal to 49 degrees, side A is equal to 95, and side B is equal to 125. So A, B, C, A is 49 degrees, side A equals 95, side B equals 125. And again, same set of steps. So solve for angle B. Sine A, so sine 49 over side A, 95, is equal to sine B over side B, which is 125. Okay, and when we go through our calculations, we're going to get sine B is equal to 0.993. So if we do inverse sine of that, we get 83.24 degrees. Okay. Now we have an angle B. We want to see, is there a B prime for that? So remember, that means we're looking for, if we have a positive sine value, then we're looking for the sine value, the other possible positive sine value, which would be in quadrant 2. And so again, we're going to solve it by doing 180 minus our reference angle of 83. So we're going to say B prime is equal to 180 minus 83.24, 24 degrees, which is going to be 96.76 degrees. Extended decimal there again. So now, again, we're basically at the same stage as we were in the first one. So our last step is going to determine, is there one possible triangle or two possible triangles? So remember, we want to determine, this is our second possible triangle, is where we have a different angle for B. Our angle A stays the same, so we want to figure out, is there room for angle C? So A plus B prime is going to be equal to 49 plus 96.76, which gives us 145.76 degrees. Okay, and so this is less than 180, so there's still room for angle C, right? So basically we could solve for angle C in this triangle by doing 180, my thing is turned off, 180 minus 145.76, and I don't actually have the extended decimal in there right now, but we're going to get approximately 34.24 degrees as our angle C. Okay, now I want to determine, is my first triangle possible, right? So A plus just our regular B angle that we solved for is going to be, A was 49, and B was 83.24 something degrees. So we end up with 132.23 extended decimal degrees. So again, less than 180. So this triangle is also possible. So both of these are possible triangles. Now if we want to solve for angle C in this one, we're going to do 180 minus 132.23 something, and again, I don't have my proper decimals in there because I'm not resolving this whole equation, but we're going to get something like 47 degrees for angle C. Then you can, of course, go ahead and solve for side C, C prime, which would be in this triangle, right? So this is our prime triangle, which is kind of like our second triangle, and you can solve for side C of your original triangle, just using the sine law, right? And we'll go through some examples of how to do that, but now you get the general idea of how to tell how many triangles there are, and a little bit of why that math works as well, with reference to the coordinate plane and how there's two possible values for sine. Okay, so now there is a bit of a shortcut method for determining how many possible outcomes exist. I don't like this method because it means that you have to do some memorization, and I mean, I guess technically you kind of have to know the steps a little bit for the one we just looked at, but this one involves a different kind of memorization where you just have to memorize some rules. And the thing I find is it doesn't really help a lot for solving for sides and angles. So this is the method that you'll find in the textbook. So basically what they're looking at doing here is you're always looking for the height of the triangle and then using that to compare, because basically what we're doing with the ambiguous case is we're thinking about how our arm here could swing either out or in, and it depends on how the length of this arm compares to the length of the other sides and the height. Okay, so in this one we're breaking our triangle down into right triangles, and this helps us to also use the sine law as well. So let's imagine we have a triangle with side A is 20, side B is 15, and angle A is 40 degrees. So A, B, C, side A is going to be 20, side B is going to be 15, and angle A is going to be 40 degrees. Okay, so basically what we're doing here the first step with this kind of method of just determining how many methods are to identify how sides compare to each other and or the height. So the thing you have to have memorized for this, once you've drawn your triangle and labeled it, is you need to memorize that in order for there to be a case where we only have one triangle, A has to be greater than or equal to the height. So side A over here has to be bigger than or equal to the height, which is this line here. And A has to be greater than side B. So A is bigger than B, which is 15. So right now we have that one, but we want to see if it matches up with the height. Now, as you can see, when we break this down into a right triangle, we have an angle and the hypotenuse side of this. If this is our right triangle, we have the hypotenuse side here, and we want to solve for the opposite side, which is our height. So we can do sine of 40 degrees is equal to opposite, which is our unknown. Actually, I should label that height, even though it's kind of confusing because that's the same as hypotenuse, but that's our h side divided by our hypotenuse, which is 15. Okay, so basically sine 40 times by 15, which gives us 10.35 something. Okay, and so this is going to be our height for the triangle. Now if you want, you can always draw that out and figure it out, but if you want, this is going to be the same calculation for all of these. Height is always going to be equal to sine of angle A times by side B. And one of the reasons why I don't always like this is because I don't know, because you're given like A and B, and of course you're not always going to be given A and B in triangles, and then you might wonder, did I assign the side right, and stuff like that. So I don't love it, but you can always just kind of keep in mind that you have A, and then side B is always just going to be the side that's matching with that angle. But basically this will be true for this triangle and for this triangle, okay? So we can kind of generalize this equation for all three types. Then the last thing we want to do is determine if the case we're dealing with meets the criteria. So we already knew that A was bigger than B, but now we want to check back. Now that we know our height is 10.35, is A greater than or equal to the height? Yes, 20 is greater than. So then we can check that off, and so now we know that there is one triangle possible. Okay. But you do have to have those facts memorized. What about no triangles? So again, we're given A equals 10, B equals 40, and angle A equals 30 degrees. So the rules you have to know for this one is just that A has to be less than H for there to be no triangle, right? So essentially what you could think of here is, actually first let's just label this 30 degrees. B is going to be 40, and A is going to be 10. So you can clearly see that my triangles that I drew here don't match these measurements, because basically what would happen is if this one's 40 and this one's like a quarter of the length, then essentially what happens is there's no way for this line would have to be like, it wouldn't reach based on this angle, like it wouldn't reach this point here. And then the other thing too is A is less than the height. So basically if you were to swing this one over, it wouldn't connect to anything, right? It wouldn't make a triangle. Whereas with this one here, if this one is shorter than this one, then we can still have it stretched out to the other side. So now we would basically say, so this is the part you would have to have memorized here. We don't know the height yet, but we have this formula. So it's going to be sine A, so sine of 30 degrees, times by side B, which was 40. And that's going to give us 20. So A, which is 10, is less than 20, which is our height. And so that means that there's no possible triangles. Okay, so that's basically where you're determining if the case meets the criteria, so 0 triangles possible. Okay, now the last one, we have A equals 95, B equals 125, and A equals 49 degrees. So 49, 95, 125. Okay, and the things you need to memorize for this one is that A has to be greater than H and A has to be less than B. Okay, so basically kind of similar to this, except for that it just has to be greater than H, and then the opposite of this one, right? A has to be less than B. So we want to solve for height. Height is equal to sine 49, so sine of angle A, times by side B, which is 125, and we end up with 94.34. So determine if the case you're dealing with meets the criteria. Is A greater than H? Well, A is 95, H is 94 point something, so yes, this one is accurate. Is A less than B? A is 95, B is 125, so yes. So then we know there's two triangles possible. Okay, so that can help you to determine the types of cases that exist, but then you're going to have to be able to go on from there and solve on your own. So that's why I wrote this little thing down here that personally I find the first method more useful. It leads you right into your calculations of sides and angles. So I personally prefer that one, and that's the way I'll be showing the examples to you guys. Okay, so the other thing I like about this method, the first method, is that I don't worry about my drawings at all. Like, so if this one I have triangle ABC, angle A is equal to 30 degrees, side A, side B, right? I'm just going to draw out kind of whatever my basic triangle that I draw every time. So A, B, C. Angle A is 30 degrees. Okay, side A is going to be 24. You know what? Actually, you guys, I did it like this on my filled in copy of the notes. So I'm going to do it the other way around so you guys can see that this is, it doesn't really matter which way I do it. Okay, so side A is across, which means it's going to be 24. Side B is going to be 42. Oh, not 42 degrees, 42 centimeters, but I'm not going to include units. Okay, so side A and side B. So still we have side, side, angle, right? Because if we go around the triangle, the angle is not contained within. Okay, so now we have our sketch. So remember the kind of things that we want to do. So the first thing we want to do is solve for our missing angle, and it has to be the angle that's across from the side because we need that in order to do sine law, right? So we would say sine of angle A, which is 30 degrees, divided by side A, which is 24, is equal to sine B, which is our unknown, divided by side B, which is 42. Sine 30 times by 42 divided by 24 gives us 0.875. Actually, that's not an extended decimal, so I'm not going to draw that out. And then I do, of course, sine minus 1 of the 0.875 gives me angle B, which is 61.044 degrees. Okay, so I have an angle B. Now remember, the next thing I need to do is determine, is there a B prime? So I do that by thinking about if this positive sign value was in quadrant 2. Sorry guys, my mic cut out, which tells me this video is getting too long. Okay, so if this one was in quadrant 2, remember that means we have to solve for it by doing 180 minus our reference angle of 61. So 180 degrees minus 61.044 degrees gives us 118.955 degrees. So that's an extended decimal. Now my next step, remember, is I want to see if there's a possible angle C. So I need to remember that I need to have angle A and B add up to less than 180 for that to be true. So let's first solve for our kind of secondary triangle, A and B prime. A plus B prime is equal to, A is 30 degrees, and B prime is 118.9 something degrees. And so that's going to give me 148.955 something. Okay, so I'm less than 180, so that means that this triangle is possible. So basically I would say then that angle C is going to be 180 minus angle A plus B prime. So actually we should call this angle C prime because it's going to go with our B prime angle. So 180 minus 148.955 is going to give us 31.04 degrees. Okay, so that's our angle C. Now that we know that this second angle is triangle is possible, we can solve for side C as well. So remember, always start off by using, like, we solved for angle B prime, but don't use that as your sine law to match up to solve for side C, because if you made a mistake, you'll carry that through. So always use your given information for the sine law, which was, actually we're going to be looking for a side, so I'm going to put the sine on the bottom. So we're going to say side A was 24 divided by sine A, which was 30 degrees. Sine 30 degrees is going to be equal to, we're looking for side C, and the angle that, actually side C prime, I guess. And so we would do sine of angle C prime, which was 31.04. And that's going to give us 24.75. 75, and I'm just going to round it off. CM is equal to side C prime. Okay, and we could always put in here angle C prime is equal to 31 point, it says round to the nearest unit actually, so I'm going to do 31 degrees, and this one would be 25 centimeters. 25 cm. Wow, that's super messy. It's going to be hard for me to leave that behind. Okay, then the other triangle we want to solve for is our original B value, right, which was the 61.044. So again, we need to solve by finding out if A plus B will be less than 180. A is 30 degrees, B is 61.044. And so yes, of course, that's going to be less than 180 because it's going to be 91.044. So then we can solve for angle C, not C prime, is going to be 180 minus the sum of the other two angles, so 91, which is going to give us 88.955. degrees. Okay, so that's our angle C, and then of course use your, we want to solve for side C over sine 88.955 is equal to side A, which was 24, over sine of A, which was 30 degrees. And so you're going to end up with 47.99 something cm. So now for our final answer, we can say C is equal to, round to the nearest unit, 48 centimeters, and angle C is equal to 89 degrees. Okay. Now, if we want, we can calculate the height to confirm that we determined the correct number of solutions. So basically, we would say, remember that height is equal to sine of angle A, which is 30 degrees, times by side B, which was 42. And so that's going to give us 21. Okay, and so then we want to think about, we determined that there was two possibilities, and so if you remember on the previous page, we said for two triangles, there should be, A should be greater than H, and A should be less than B. So A greater than H, A less than B. Is this accurate? A is 24, height is 21. 24 is greater than 21, so that one's accurate. Is A less than B? A is 24, B is 42. Yes, that's less, so we can check that off. So then we can always write this confirms two possible cases. Okay. All right. Let's go through. I believe this is our last example, and then you guys have a chance to try one on your own. So I apologize that this is a longer lesson, but it's a fairly complex subject, so hopefully you guys can bear with it for this one time. So example number 2, we have triangle ABC, triangle A equals 150, A equals 17, and B equals 10. You guys can always pause the video here too and see if you can figure it out on your own first, and then I'll walk you through the solution when you come back. Okay, so let's see, we're going to do A equals 150. Side A is equal to 17. Side B is equal to 10. Okay. And we want to determine the other measures, right? So very first step is to solve for angle B. So it's going to be sine of angle A, which is 150, divided by side A, which is 17, is equal to sine B over side B, which is 10. Sine 150 times by 10, oh, this pen is getting leaky, divided by 17 gives us 0.294, so the inverse sine of that gives us angle B is equal to 17.104 degrees. Okay, so the next thing we want to determine is there a B prime, right? So B prime is always going to be 180 minus 17.104 degrees, which gives us 162.895 degrees. Now we want to determine, is there a possible C prime? So remember that means that A plus B prime would have to be less than 180 so that we can still add in the third angle C. So A was 150 plus B prime is 162, so you can already see that is not going to work. Okay, look at the filled in notes for the tighter version of that. It does not work because it's greater than 180. So now we want to see, can we make our angle B still work? So that would mean A plus B have to be less than 180. A is 150 plus B is 17.104 degrees, and that gives us 167.104, so that does work, less than 180. So we can solve for angle C because it should be 180 degrees in the triangle minus the sum of the first two angles, 167.104, which leaves us with room for a 12.895 degree angle, so a really small angle for angle C. Because of those other two large angles, but that's fine. So now we have angle C. The only other thing we would want to solve for is side C. So C is going to be equal to, divided by sine of angle C. So sine of 12.895, which is equal to, always use your original values. So side A is 17. Divided by sine of angle A, which is 150. Sine of 12.895 times 17 divided by sine of 150 is going to give us 7.587 centimeters. We want to round to the nearest unit, so in our final answer we would say side C is 7.5, so 8 centimeters. Angle C is equal to 13 degrees, 12.8. Angle B is equal to 17.104. Oh no, sorry, I'm rounding off. 17 degrees. So those were our missing sides and angles. Okay, and if you wanted to, you could always go back and do your confirmation to check and see if it's true that there should only be one case. Personally, for me, I find like this is good enough. I don't really need to go back and confirm. So if you pause the video and you did that one on your own, good for you. There's a chance for you to do another one on your own. 2 possible triangles there. And of course the answers are down here below. Maybe don't look ahead of time because it'll help you to figure out how many triangles you should be doing. And then there's an assignment here at the bottom as well. There is, I did mention you can always review the Sine Law key IDs on page 107, but just be aware that they're going to have some slightly different methods for the ambiguous case. So if that throws you off, don't worry about it at all. And next time, oh, sorry, and actually I did put in some even more extra practice in here. So there's the ambiguous case triangles, a bunch of extra practice. There's an answer key here. And then next time we're going to be looking at the cosine law, and that is our last lesson for this unit. So you guys are almost there, and I will see you then.